Hello, everyone, and welcome to this session of Quantopian Book Series. We are very honored and pleased to have Jiri Pik, Ernie Chan, and Jared Broad with us, who are the three of the five authors of the book that we're going to discuss tonight. And the book is called Hands-on AI Trading with Python, QuantConnect, and AWS. So I will just start by giving very brief introduction to all five authors, and then three of whom who are here can get into more details and talk more about their own background, the way that it relates to the book, how it was integral, AWS Quant Connect in particular, to the book, and then we will go the usual way of questions. So first of all, welcome Jiri, Ernie, and Jared. Yeah, I'm very happy and pleased to have you here with us. So Jiri Pik is the founder and chief executive officer of Rocket Edge at rocketedge.com, a creative consultancy focused on cloud computing, artificial intelligence, and ultra low frequency financial trading. With over 20 years in financial technology, he has collaborated with leading institutions like Citi, Goldman Sachs, and holds all 12 AWS certificates. Wow. Okay, so that's really nice. 12 AWS certifications alongside several Microsoft Azure certifications. Ernie, whom you will remember, I'm sure, from before and from the other book that we discussed a couple of months ago, I think, is the founder and chief scientific officer of PredictNow.ai, specializing in machine learning solutions for risk management and optimization. He has a PhD in physics from Cornell University. He's a pioneer in AI-driven finance and acclaimed author of four widely published books on quant trading, going back many years when the very first book came out, and I was joyfully reading that in the hopes that even retail investors can be someone eventually. Jared Broad, and I'm sure that you have heard Jared's name and you have heard definitely QuantConnect's reputation, founder and chief executive officer of QuantConnect, an open source algorithmic trading platform serving thousands of quant funds since 2012. He holds a biomedical, which I didn't know actually. That's so interesting. Physics, biomedical engineering, it's a variety of interesting scientific areas that converge in finance. He holds a biomedical engineering degree from University of Auckland and has dedicated his work to advancing accessible algorithmic trading tools. I'm sure that almost everybody here in this audience and those who will be listening to this on YouTube channel and otherwise are familiar with QuantConnect, and they have tried lots of their thoughts and ideas there. So the other two authors who are not here is Philip Soon, Chief Executive Officer of Adaptive Investment Solutions, where he leads the automation of options overlay strategies using machine learning and AI innovations. He is also an adjunct faculty at Boston University, where he teaches algorithmic trading, drawing from his experience as a senior quant at top firms like Fidelity and Sentinel Investments. And finally, Vivek Singh is a senior product manager at AWS, spearheading the development of generative AI services, including data annotation and fine-tuning to ensure safe and responsible AI use. So there is this nice, by the way, in parentheses, aspect of ethics and responsible AI discussion that I'm hoping that we can also get into on top of everything technical, so to speak, which more and more is gaining momentum and importance, as it should. Previously, he worked in fundamental stock analysis at a large hedge fund, showcasing his diverse expertise in finance and technology. So welcome everyone, and let's maybe then start by going through, as always, the first question: how did this book come to be? The genesis of the book, and how did it get the five of you together to create this? And then within there, you can add anything from your background that you see.
Jerry's just a magnet, and he somehow brought us all together.
Oh, okay.
Reached through the vines, and yeah, go on, Jerry. How did you do it?
Thank you so much, Jared. The book essentially started, we identified a gap in the market. That while there are a lot of books about AI trading or financial trading, most of the books have very scattered descriptions of AI methods. Our goal in the book was to collect all the relevant AI methods into one single piece, in one single book, and also to focus entirely on the on teaching intuition and insights into how the AI method works. We did it because the entire book uses extensively QuantConnect. QuantConnect is extremely useful for the book because it allows us to use market data and the best practices for backtesting out of the box. Most other books, similar books, spend half of the contents on setting up infrastructure, on the problem of getting market data, correct market data, and so on. In our book, we eliminated this problem by applying QuantConnect, and then we managed, thanks to Jared and Arnie and the other two authors, we managed to identify the key driving AI methods in the modern finance. For each of them, we created representative examples. Each of them has a different perspective on the AI finance and how the method works. And we identified the key problem areas of each method, whether the market data needs to be normalized and so on. And then we organize them in the order of increasing complexity. The idea was that if a quant wants to master all the techniques, he should start from the scratch, from one example by another example, and go through the chapters and play with the examples. Let's say modify one example and so on. And the beauty of using QuantConnect for this is every single reader can modify the assets we are trading. So, for example, if our book focuses on gold, he can modify it to using silver and see how the performance differs. And then we were very lucky to include Ernest Chan, who is at the frontiers of predictive AI, which is one of the new technologies in the market.
Yeah, thanks, Jiri. So, yeah, I think that, when Jiri reached out, to suggest maybe I should include a chapter in the book, I was quite excited because, over the last few years that I've been running Predict Now, we constantly put out content on the different techniques that we develop. Our objective at Predict Now is innovation. We are not, just recycling known techniques to serve clients. We try to, find new ways of applying machine learning to risk management, to optimization, to serve our clients. As a result, we oftentimes write either, a blog post or in some cases, read published papers to sort of expand on our techniques. But all these little pieces of information are, scattered everywhere. So, when Jiri mentioned that maybe it's this book is an ideal place to collect all these thoughts together in one place and in fact provide an example where people can see how it works in action. Whereas, in our blog posts, we typically go, talk about at a high level, where in the book, we actually come with a sample Python script that you could see how it works in practice. So I jumped at the opportunity to collect these things into one place.
Unlike my other esteemed authors, this was our first experience with the book. So I jumped in at Jiri's bequest with the same presentation that he just gave. But I was in complete ignorance of the work involved. So I think it was about a year and a half ago, he was like, hey, let's write a book. And it sounds like a great idea. And then a year later, it was finally reaching publication. So yes, it was Jiri moving heaven and earth and the whole team coming together to pull all of these examples and try to put it together in a cohesive way so that people could learn incrementally. It's really hard to get into the space sometimes, so it's nice when it's like the foundations are laid and then incrementally, practically, step by step through the book.
So for those who in the audience, so I just want to maybe very briefly say what the structure of the book is. There are 3 parts to the book. So it comes in 3 parts in a total of 9 chapters. The first 2 parts are foundational conversations and discussions and material. Part 1 is Foundations of Capital Markets and Quant Trading, and 2 chapters there. Part 2 is the Foundation of AI and ML in Algorithmic Trading with 2 chapters there. And then the remaining chapters are in Part 3, which seems to be the heart of the book, if it is a fair assessment, as well as your design strategy seems to be manifesting itself in that chapter, the first chapter of Part 3, which is chapter 6, Applied Machine Learning, where you have 19 examples.
Over 20, 21 or 22, depending how you count it.
Okay. So then the idea is that, so for somebody who wants to really dive deep into this book, then the beating heart of the book is like those examples that one needs to take, digest, based on, of course, the material before. If they don't know the foundational material, okay, so maybe it's a better idea to study that first. But go to the examples, play with the examples, look at the implementation of examples. You don't have to worry about the code. You don't have to worry about the infrastructure. Connect gives you all of that. And then start on the journey of maybe innovation, changing something, adding something, taking away something. Okay.
Yeah, exactly. We encourage curiosity. Each example has different AI techniques. The best way to proceed is take one example and modify something. Modify, for example, asset class. Instead of MSFT, try Apple. Instead of aggregation by months, aggregate by quarter. Instead of using geometric averages, use something else. And then what we recommend is to combine the techniques from different examples into one example, because this gives you another advantage. And then we recommend asking, what would happen if we change this and that? And also, most of the machine learning techniques have parameters, like hyperparameters. And the beauty of using QuantConnect is that it has optimizer. What it means essentially is that it's very simple to play with the parameters to find the right set of parameters for the particular example. This is revolutionary because it allows you to quickly see if I change this asset class, what would be the right parameters for this particular neural networks, how many layers, and so on.
Mm-hmm. So they are already implemented then in that infrastructure. You don't have to.
Yes. So QuantConnect allows you to do Jupyter research, backtesting, and then optimization. And the optimizer and the backtesting are very tightly knit. So you can define a variable in a strategy and then adjust that as a parameter in the optimizer. And so it's just the same, definition, like a normal variable definition in Python. It'll just be able to pick up and change that variable, and you'll see a heat map of how the strategy performs over all the different variable values. So the whole environment is set up as a cloud-based IDE. So when you log into QuantConnect, you're opening a Visual Studio Code environment, and you're writing Python in the browser just like you would locally. And so you can create a new algorithm. There's hundreds of examples, and it'll just load the coding environment and start with a basic template. So in this simple template, we're requesting data, and then we're firing events. QuantConnect broadly is an event-driven backtesting engine. So you are just driving data into event handlers, and then we calculate the portfolio and process all of the order fills and all the critical parts of the system. And then you can run backtests, and this takes your code and fires it off to a cluster attached to hundreds of terabytes of financial data. So we have 12 asset classes, about 60 different alternative data sets, and all of the corporate actions and mapping and linking to securities, the mergers, acquisitions, splits, dividends, etc. That's all handled by the engine under the hood. So then, you can dive in, see the trades and all sorts of other things. We have the Jupyter research environment, so you can use the same API that you're requesting here, but you can use it in a Jupyter research and do batch analysis and then a parameter optimizer. So I'll jump to a tangible example here, but just to complete this one. Once you've got your strategy and you're happy with it, you go through to the live deploy, and you can go through to, there's about 25 brokers that we go through to directly. And then we go through to all the routers like the Bloomberg EMSX, which goes through to all the primes and that sort of thing as well. Or you go to paper trading and just hit deploy. So we handle the cross connects, the live colo, the data feeds. Your Python just gets deployed in a virtual server, and it's running in Equinix in New Jersey, and you're good. You can just walk away. So today we have about 3,500 paying clients, users of QuantConnect. There's about 500 hedge funds in that mix. And then in total, they do about 60 billion in notional live trading each month. So they range from 500K startups to 35 billion funds. And they can just go through and deploy a strategy like that. So for this quick class, I just wanted to show you a quick demo of a classic, just in case everybody's heard of the Piotrowski F-score strategy. So it was a very popular paper published about 25 years ago. So it's just a simple F-score where there's a fundamental data scoring system. There's these different criteria, and each criteria gets assigned a point. And then when the score of the asset is more than 7, it can be included in the universe and allocated to. So to do that in QuantConnect, it's just a few lines of code here. We've got some start date for the algorithm. We're going to be doing every month. We're going to rebalance when the algorithm starts trading. We're asking for hourly resolution data because it's just a monthly rebalance. And then when we get an asset, we're just going to hold the asset for 30 days when it enters the universe. From there, we're going to be weighting it by sectors. So we look at the sector classification for the asset and determine, so we equally weight across the sectors, and then make sure that we're not executing when the spread is too wide. So we reduce the liquid assets in the portfolio. So this is implemented with this universe selection model. And so using just 10 lines of code here, it is able to filter through the entire Morningstar data set, every asset that's ever traded, and then it gets all of the fundamental properties on all of those stocks, and then finds all the ones with a price more than $1, and in this case, a dollar volume more than $100,000, like they're trading somewhat. And we're going to go and get the Piotrowski F-score for that asset. So that's calculated with a helper class that we made. So we've got these little helpers, and it's just pass in the fundamental data and go and get the operation ratios and the operating cash flow and go through these different factors that are part of Piotrowski's formula, magic. So go and get those different factors, and then they just sum them up. So using it, you can sum up the score for all the different factors that they're looking at and use that for that asset here. So once we've got this dictionary of F scores, this is all the assets and all their scores, we can go and run this and get all the best scores and then select a universe. In this case, we're just selecting the top 100 for the demo. The original paper just selected all of them, and it's totally fine to do that. I was just trying to make it run 6 seconds faster. So it's like 18 seconds. So this will go back. I tweaked it just to run for the last few years. So it's running the back test across all those assets, scanning the fundamental data, generating the scores every single month, and then rebalancing the portfolio each month. And so we can see all the normal stats you would expect, equity, etc. We can see the margin allocation, the drawdown of the normal statistics, and then there's all the detailed trades, how the orders were filled. So this is the back test. And then for this, we were thinking, how should we parameterize it? So they have the score threshold, which is the minimum score of assets to be included in the universe based on the Piotrowski algorithm. And then here I just set a universe size of 100. They were looking at thousands and thousands of like penny stocks almost. So we played with another one here, ROA multiple, which was something I'll get to in a second. But for the optimization, you can run the optimizer on those different variables, and it goes through a range. So you've got the score threshold, the default value, the minimum and maximum, and it'll just go and run backtest after backtest on all those different combinations. And then you'll generate a heat map like this. So you can see that the impact of the parameters on the backtests. And so the idea is to test the sensitivity of your strategy to the different parameters, and to see, for example, here we've got the score threshold of 7 and the score threshold of 8. The Sharpe ratio drops by half. I'm not sure if you guys can see that, but it's a 0.8, 0.9 Sharpe ratio for score threshold of 7, and then 0.4 for score threshold of 8. So it seems very sensitive to that parameter. So it might be a bit of a hint that it's overfed or something funky is going on there, and you want to be careful with trusting it.
So the beauty of QuantConnect is that it allows you to amplify your abilities. Right. To create everything which QuantConnect offers by yourself, it would take years. So that's the primary reason why we chose QuantConnect for the book, because it allows you to focus entirely on the strategy and play with different parameters, different parameterization, and see instantly the results using the best data, which is also important.
Well, yeah, extremely. Yeah, I would say definitely the data. So what are some of the things that you can tell us about the data behind this?
The primary source of market data for QuantConnect is AlgoSeek. In one of the projects for a client, we have done an extensive research of market data on US equities. What we have done, we have asked for the largest 10 market data vendors for identical sample of market data. So we choose 10 representative stocks, a representative period, and ask them, all of them, to provide us with market data. So in theory, the market data should be identical. But in reality, what we found out is that there were major problems. Data was wrong, data was missing, there was artificial data, and so on. And in the end, for this client, we decided that AlgoSeek was one of the best sources. And this is very useful.
And the things you mentioned about the importance of the data, first of all, the way that one cleans the data, and then the ways that one looks at perhaps generating new features from the existing features in the data, or one looks into rescaling various different things so that one doesn't hit in the machine learning part of it some unusual emphasis on something which doesn't really warrant that emphasis. So these are also part of this pipeline in QuantConnect that you can go and say, hey, I want time bars, I want volume bars, I want dollar volume bars for my backtest or for whatever else that I'm doing.
Yes, correct. And they are included in QuantConnect API. And also in the book, every single example has a different portion describe different ways how to implement these. So if you go through all the examples, you will see implementation of all of these.
I see. Okay. So it may change from one to the other depending on what is more sensitive to. I very much like this parameters. I mean, this grid search or random version of that, these are they turn out to be probably the only way that one can, in fact, decide on something as opposed to any kind of theoretical investigation that proves the optimality of some. It's just.
Yes, I know. Yes, in some of our research, we literally make random trading signals so we can test the pure data. Just the only other thing that I wanted to mention was the more native way that a lot of people are used to working with data and with quant research is with Jupyter Research Notebooks. Right. So a lot of the examples come with Jupyter Research Notebooks that we've implemented in the book as well. And we were able to pull in large volumes of trade bars and do batch analysis, however you like as well.
Excellent, excellent, excellent. Yeah, this is absolutely very nice. So let me immediately ask a question, and well, two immediate questions. One is there any way in the pipeline that you get connections to large language models or connection to any generative AI tools within QuantConnect? Like, is there in QuantConnect a way for me to ask ChatGPT something and then bring that into my strategy, for example?
Yes, we host some models from Hugging Face.
Okay.
So we're pulling those locally, and you're able to instantiate a Hugging Face model. And then we have GPU machines where you can load the Hugging Face model into and do your inference, but not for fine tuning.
In addition, the book includes a general description of the algorithms. So if something is not possible, you can either use a lean version of QuantConnect, which is running on your computer and you can do anything you want, or alternatively, you can synthesize the ideas from the book and use it elsewhere if actually needed. But we believe that the book in integration with QuantConnect and lean is the most effective way how to master the algorithms.
Okay. So what was the role of the infrastructure in terms of efficiency? Was it always efficient? Were there cases that you felt like, oh, this could have worked in this particular case in a different type of environment better?
I suppose it depends where you anchor the start. Because I think Jiri opened with most other books spend the entire book talking about how to get the data. So if you anchor from, I already have all my data, I already have all my backtesting engine on premise, I already know my backtest that I custom wrote. Probably people have custom wrote their own backtest or whatever. maybe it can be less efficient to use QuantConnect.
Mm.
But for 99.9% of people, it's 1,000 times cheaper and 1,000 times
Oh,
faster.
absolutely. Absolutely. Both cheaper in terms of, money, and cheaper in terms of invested time and energy and brain work that goes into creating these things and troubleshooting these things, debugging these things. And at the end, again, you're not sure 100% if it is working correctly or it is giving you accidentally some correct. So no, I mean, having the infrastructure, I think, is a huge, huge advantage to. But of course, ideas behind these things, I mean, the beauty of the examples and the way that they are carefully, nicely designed to show different points and different aspects of this. Like I'm looking the temporal CNN prediction, the PCA, the whole PCA approach, even a case of analysis with CNN, head, shoulders, pattern matching. So I mean, you very nicely captured the different dimensions of quant trading. But so that's extremely important. But really having this infrastructure boosts it even more beyond.
I think one of the common things that we hear from people is, oh, I started building with something myself,
Yeah.
and then I tried to do this. And the boss says, hey, we want to start adding options to hedge our equity portfolio. And then they're like, oh, so now I need to go and throw everything out that I've built and re-engineer it with options and try and buy some data. And options is 1,000 times bigger than equities. And so it's just that you don't know what you don't know yet. And as you go on your quant research career, you need the flexibility to try those different ideas.
Yeah.
And when a lot of times, if you just duct tape your own thing together, you don't quite have that flexibility, and it can be 6 months to test those new ideas.
No, absolutely right. No, and I would also add at the end of it, even believe it or not, of course, it is not that much of a big deal compared to the rest of the challenges that we were just talking about and you were just talking about. But even the transition from a good idea, which performed really well in a backtest, to paper trading in a good environment, and from paper trading to live trading in the same environment, is a huge advantage. I mean, it used to be, for God's sake, that there were different languages even. You would use MATLAB and you would do your understanding and your theory and everything, and you would do your tests. It would do great. Then you had to do the paper trade. You go to one or two places available to you. They want, I don't know, C#. Okay, now let's write the whole thing. And then to live trade somewhere else, want C++ or Python or a completely new environment. So even that you showed that you can easily go and choose the paper trade, choose the live trade, choose whatever you want, and more than one option for that even. So I have many more questions, but I wanna give the audience the opportunity to ask questions as well.
I've been recently invigorated with AI, not to do machine learning for different signal, but because actually the AI writes all this long, painful code for you that you would otherwise not want to write, both in terms of the plumbing, but also the research analysis. It's like having a thought partner there to push you around. I'm just wondering whether the book sort of tackled this part. Now, and I get the QuantConnect stuff, and I think that stuff looks nice. As you said, it's not for me because I built my data and I have my thing. But I really think that the AI for this space is more valuable right now and in the next year in terms of getting people to do things that would otherwise be too much learning for them and too much coding for them to figure out. But I don't know if the book sort of touched on that part of AI.
There is a Gen AI chapter in this book, but I didn't write it. So the chapter I wrote is more on applying AI for risk management and optimization, portfolio optimization to be very specific, and also for features engineering, the dirty work that comes before any AI is done. So maybe, Jiri, you have some insights on what's covered in the Gen AI chapter.
Thank you, Ernie. The Gen AI structure is largely, it doesn't address in detail the question like design for me a trading strategy, design for me the markets, the backtesting system. It doesn't do that. It teaches you the general architectural base, how to prompt, the basic prompt techniques, but doesn't go deeper into the trading strategies designed by Gen AI. In my experience with using ChatGPT or Claude for designing trading strategies, the results are usually flaky. The problem is that the strategies designed by Gen AI are not robust enough. They may be robust in certain areas, but if you consider all the nuances, all the market regimes and so on, it's not yet perfect. In my experience, Gen AI is extremely good for doing basic stuff, like generate for me a report on this, generate for me, identify what is the purpose of the code, speed it up. But to design a trading strategy from scratch, I wouldn't do that. It doesn't work.
Yeah, I guess that wasn't really where I was going with it. I meant that if I wanted to learn how to actually do a long-term, short-term memory model against my data, it's amazing what it will show you in Code Interpreter and explain to you what's going on in a way that used to take reading a book for a week to get, and then hacking around to try to translate from the page of the book into whatever you're doing and whatever your data is. Yeah, no, I don't. Obviously, we'd all be in the quant trading business out of business to the extent that the AI is smart enough to come up with strategies that on its own that, then all the inefficiency in the world will be gone other than the cost of the compute to find it. So
if you would like to ask ChatGPT for implementation of particular AI method, I don't think that it would be much successful because the training data for the ChatGPT also is not strong enough. I'm aware that some hedge funds or big banks are custom training their own ChatGPTs or GPTs using all the papers in the wild, all the financial books, and then you have a good chance. But using general ChatGPT, I don't think you would get good answer.
If I can, Michael, I had a presentation literally on Gen AI and finance tomorrow morning, and I have the slides here. We started a project for the community to rewrite our documentation in 2020. The community was just outraged by our docs. And so we spent about a full year working on it with a third of the team. And we just rewrote about 50,000 sections of documentation. It was a mammoth project. And then LLMs took off and really became popular about 2022. And they scraped everything we had done, and then they scraped our open source, and they scraped 10,000 examples from our community forum. And then it was even by like January 2023, QuantConnect was like the default recommendation for algorithmic trading out of ChatGPT because it knew how to write algos on QuantConnect. But what we found was the public models, the ChatGPT 4.0 and the rest of them, this had like a 25% success rate at being able to just run a backtest with the code that it's generating from GPT, let alone like building AI models off your data and that sort of thing. And so we went in 2023 and started building these test frameworks and what are now called workflows. So workflows are this structured prompt pathway where you have micro prompts that do little tasks, because the big task of like just build an AI quant trading strategy is too much for most LLMs. So we built this like structured prompt pathway. And from the user's point of view, they just saw this. I put in my prompt and I get code. But behind the scenes, we were like running syntax checks. We were getting the compile errors. We were feeding it back to the LLM. We were running a back test, feeding it back to the LLM, and then doing this big recursion thing. And it would be like a minute later, you would just get code that just worked. And then we had this test suite that measured it at about 76% of the algorithms that you asked for generated successfully. And then finally, now people are releasing something called MCPs. I'm not sure if everybody's familiar with them, right? And so MCPs are kind of like the latest generation of AI and LLMs. And so we've released an MCP recently with all those same tools And we didn't really understand the word agent in 2023, but now I get it.
No,
Because
you had a coding agent back then. You were doing the feedback. Yep.
we're doing the feedback very manually and very like linearly. But the
Yep.
thing with the new MCPs and the new agents is they're just completely recursive.
Yep.
And they just do everything themselves. They come up with their own plan. They build and execute their own plan. They're just using you for reference to run the back tests. And that is absolutely epic. So here, I believe there is a much more positive chance of the AI being able to do what you're saying. It will be able to write an AI model using your data. It'll fail. It'll try again. It'll fail. It'll try again. They'll read the website,
Yeah. No, I mean, I'm doing it today. Like if I wanted, my questions of like, there's a lot of collinearity. What are the, 4 or 5 things I can do to deal with that in code
Yeah.
interpreter with GPT-5? And it will run all 5 different kinds of regressions, right? Give me back stats, give me back this, give me back that. Yeah, it's agent text. So the first time the code runs, it's going to hit an error, but it'll fix its own error and then it'll go back. And it's shockingly good at not just saving your time writing a lot of boring lines of code, but it's shockingly good at explaining to an intelligent person some concepts that used to take an intelligent person literally going to the library or nowadays, sifting through the web, spending hours and then trying to figure out how to do it. It just kind of, it's a great teacher. And I just think that a lot of the nice part about that I saw on QuantConnect, for example, like people are you need to figure a way to open that where AI in a year or two, when it's better, will take those blocks and build people exactly what they want. You have to get the agent building in there. And some of the structure that you've put in there just opened up to agent tech. And it'll really be a product that is very easy to use, because you want to add, you're looking at that and you go, this is great, but I've got my own API. It's private. It's not connected. I don't know. Maybe you've built that facility or not. Like in 5 minutes, GPT will come up with Python code that has more error trapping than I would ever possibly write myself and link this stuff up. And it's especially enjoyable when there's 25 structured data fields of all kinds of variety that you as a human being would exhaust yourself trying to get right the first time, and then you would debug for an hour watching all the crashes happen because you weren't particular enough. So I mean, that's just mine. Sorry, I didn't mean to take over this conversation, but thank you. And thanks again, Ernie, because your ideas sort of pushed me off into a different direction in life.
Go ahead. You did it. Thanks, Michael.
So along those lines, while you were talking about all of these advances in AI and how they are basically taking over, I looked at the list of questions that I had received, and one of them is very relevant to this. So it says basically, if you were designing a quant firm from scratch today, but even more generally, I would say, how would you combine human judgment and AI systems for decision making? In other words, what will be the role of the expert, the role of the quant, if we can even call somebody quant at that point, like in 10 years? How do you combine the two?
Well, I would say that nobody knows what will happen in 10 years. Maybe AI will have taken over the world and we will all be on just permanent vacation. But at this point in time, the human is required to be in the loop when you develop a new strategy, because you need to pass the smell test. You need to provide sort of basic sanity to the model, right? So even though a lot of the code might be correct, but there's no guarantee that 100% of it is correct. So I'm glad in the system that Jared has pointed out, that it has sort of internally check and balances to make sure that whatever the LM spill out is it can be back tested and can be validated, and it will feed back into it and say, hey, this thing doesn't run. What are you talking about? You can't, get a signal that, at the close but however you enter a trade before the close, that sort of thing. So I think that at this point in time, you can't have a totally autonomous strategy development process yet because of that kind of issues. You can see even when you apply LM to mathematics, which is, a much more straightforward problem than a lot of trading problem. And, you can see that, sometimes it can perform at the level of a international math Olympiad winner, and other times it fail at very basic logic tests. So, I've used Gen AI for, a year or two, and I've seen the same happen over and over again. There are flashes of brilliance, and then there are just utter absurdity. And so you don't know, if you are not an expert already in the field, you don't know whether what comes back is absurdity or if it's genius. That's the problem at this point.
At this point, yeah, I agree with that. I agree completely. The example you give in math, I've seen it many, many times. In trading, I haven't, because I haven't done that much of it using AI, but in math, definitely true. Can solve very complicated geometry problem that would take a long time for, like, thinking of unthinkable almost at that moment, but then fail in a very, very simple calculational matter or something along those lines at that level. So it's hard to know really. So I have two other questions that they were asked, and I will ask you those. But before going there, I wanted to maybe if you could tell us a little bit more about the reinforcement learning part of things, because it was interesting to see that chapter 7 on better hedging with reinforcement learning. So I was wondering, like, how reinforcement learning, what is your perspective on that? How do you see that? Where do you find it very useful as opposed to not so useful in other areas?
Unfortunately, the person who wrote that chapter is not here. So we can only sort of, give our, pedestrian opinion on that. Luckily, I personally finished a deep reinforcement learning project over the last half year. And, in general, reinforcement learning is good at optimization problem. The problem that does not have a defined truth, in other words. In fact, problem where nobody know what the truth is. Whereas in generally, supervised learning or even generative AI, oftentimes you know what the truth is, and you're just trying to get the machine to predict it or to infer it or to automate the process of getting the truth. In reinforcement learning, nobody, no human, no machine, nobody else, no nothing knows what the truth is, and you are just trying to incrementally get towards a better and better goal. So that's the general philosophy of reinforcement learning. Now, in practice, the problem there's one fundamental problem with reinforcement learning, which fortunately does not affect finance so much, but it affects other applications. And that problem is the fact that there's no counterfactual in training a reinforcement learning problem. So let's say you are trying to train a reinforcement learning system on pricing groceries in a supermarket, right? So your supermarket CEO heard about this and said and hired us to build a reinforcement learning system to dynamically adapt the butter prices, the bread prices, and the soup prices and so forth, in order to maximize their profit. The problem is that even if you have a great set of data, you have only one set of prices in the past in determining and one set of demand. So you have one data point in the past matching demand, prices, and supply. Whereas reinforcement learning, when you are training it, you need the counterfactual. Say, what if the prices are different? Would you drive up the demand so much, or is the demand so inelastic that lowering the price doesn't change anything? So in real life application of reinforcement learning, that it often runs into this problem, and so that's why in applying reinforcement learning to large language models, you actually need to first create a reward function using human feedback. That's the whole concept of reinforcement learning with human feedback, is that you actually need supervised learning to build the reward function. Fortunately, in finance, that problem is seldom encountered because, in finance, it's almost like a video game. You can always say, well, what if I make that other trade? What would be our reward? And you have solved that fundamental problem. So I would say that reinforcement learning is, at the outset is particularly suited to finance because of this property that you can simulate and you can rewind history and see what the alternative scenario comes about. The problem is reinforcement learning has oftentimes create a large variance of outcome. You really need to run, and I've seen successful reinforcement learning system having to run in parallel, maybe hundreds of agents in parallel and average them in order to get result because it is highly path dependent. Unlike supervised learning, there's no path dependency. Reinforcement learning is highly path dependent. So every time you have, it's almost like the butterfly effect in chaos. Every time you start something slightly different, it ends up in a completely different place. In order to get any sort of concrete result, you have to average over a large number of agents. And as a result, of course, people have all kinds of methods to reduce the variance, PPO, the proximal policy optimization, and this and that. All these methods are invented by, some of them by OpenAI and so forth to reduce the variance. But at the end of the day, the variance is still significant, and you need a lot of agents, you need a lot of computational power. So every time we run an experiment, it takes hours to finish, even on a GPU. So that's the flip side, the problem of applying reinforcement learning to finance in general. So we have successfully completed a reinforcement learning problem, and the result is that regrettably, it's not necessarily much better than simpler methods at this point.
That's it.
Now, and that's after 6 months of work. Now, of course, we spend another 6 months, might be better, but it is a very time-consuming and computationally heavy technique for application even in finance.
Okay, I see. Okay, thank you. That was really great.
Philip's chapter was applying specifically to option insurance as well, picking the right strikes and when to sell the option contract. And so it's, again, even also an incredibly intensive data set.
I had seen before applications in sort of an agent that learns to trade by interacting in the reinforcement learning mechanism with the limit order book. So we'll look at the limit order book, we'll make some choices, and we'll get the feedback, and we'll keep, therefore, at each stage deciding on what to do, how big to do. So the size and the side of the trade. And then later came all these applications to option pricing, different, but I haven't seen anything really significant beyond these two areas, like the option world and the limit order book world. And I thought somewhat that limit order book application looked like as more successful, but again, I don't know because I don't know the literature that well. That's why I ask, if you encountered something really interesting there that was like not seen before. So let me ask one question of these, a couple of questions that was sent to me. So it says the book touches on large language models and generative AI. What new roles do you foresee for LLMs in trading? Research assistants, strategy design aids, or even autonomous agents? What is your it's hard to predict that far into the future. And some of this, Ernie, you alluded to, where it can be or is now. But do you, like in your imagination, do you see what is coming with LLMs in trading?
One of our, audience member, Michael, suggested it really, 10x our productivity. That is for sure. Both in ideation to backtesting to risk management to coding. Now the problem, of course, and also as Michael suggested, that is that everybody has LLM in the disposal, so you don't have a unique advantage, and so the alpha that you created, similarly, will suffer similar alpha decay, no matter how much LLM, how good at LLM you're discovering. The market, unlike, self-driving car, I often say to people, the problem with applying AI to finance is unlike applying AI to self-driving car, which can only get better. I mean, if you have more data, the car will drive itself better. The more it drives, the better it gets. It doesn't do that in finance. You get more data, more AI, more people working on it, and everybody get less profit. That is unfortunate. But that's in a sort of a market neutral context, right? I mean, we're talking about trading, absolute return context. Now, if you're applying LM to a long only strategy to discover, let's say I only want a long stock, and I want to find out what stock to long to, to have the best Sharpe ratio I can have. Now, LM, that is not alpha that you're trying to extract because you're long only. You are trying to perhaps just to decrease the volatility of your portfolio. So, maybe everybody will agree that they should be holding just certain index. Here's a nuance I often find very interesting. You read many books that suggest that, well, you should really, if you're a retail investor, you should just hold an index fund. That many books have said that. You forget about trading, forget about investing in hedge fund, just hold an index. And my answer to that suggestion by very prominent authors, very successful long-only manager is that which index, sir, should I invest in? Because there are many. And each index has its own construction. So just to decide which index is not a trivial problem for a retail investor. And so, one way that, for example, LLM can guide us is to decide, which index over the long term is best for a particular investor circumstance. That may not be an alpha in the stricter sense, but it is a very helpful for the average investor to have that kind of guidance.
So it has some form of still in the form of assistant, research assistant, maybe ideation, to some degree, ideation, research assistant. And if we envision specialized agents or specialized LLMs, so to speak, that can then specialize in particular sectors, particular markets, particular assets, they could probably also be better sort of experts in this advice that they give. But ultimately, it seems to be, for now at least, like in a consulting type of role.
I look at LLMs and I see a mix of what they are and what they aren't. And they aren't physical. And they're constrained by the physics of the hardware that they're running on. So, for example, QuantConnect's data repository and the licenses that we have to sign to get access to that data. No amount of LLMs, and if it auto-generates 1 billion lines of code, it still won't have data, and it still won't have cross connects to other people where we've got contracts and things in place. So LLMs aren't physical, and they have physical limitations, and LLMs are excellent at glue. They're excellent at gluing two things together in a very dynamic way, and they can take whatever input, and it can make you super productive. So having those two kind of polarities of what they can do, I see them being excellent at Michael's comments. They'll be excellent at implementation, and then the limits of what they'll hit will be basically where we see MCPs today. I don't see them being able to implement Dropbox because Dropbox has servers and hard drives, and redundancy and stuff that LLMs just can't make. So in finance specifically, yes, it's excellent at taking your ideas and executing them, gluing APIs together. If you're building your own frameworks, maybe it can help you build a scraper and whatever, that sort of thing. So the other thing that the LLMs don't have is eyes and physical experience yet. So maybe if we take an LLM, we throw it inside those humanoid robots that are coming out, they'll start getting eyes and brains and real world experiences. And then they'll start coming out with alpha. But until they have eyes and taste buds and stuff, I don't think they're going to come up with alpha other than just averaging out what they see on the internet. But I don't think that's that far away. I think people are really working hard on AI, LLM, humanoid robots for a reason. And I can see them having unique experiences and then being able to derive unique insights from those experiences. But it's probably 15 years away. We have excellent LLM robots with their own GPUs come up with their own insights. So, 15 years.
But so isn't it interesting, though, when you look at publications, look at literature, you see hundreds of papers being published every month, okay, if not a month, in like every quarter. There are hundreds of papers published in this space, related to spaces, LLMs in finance or otherwise, but you hardly ever see anything that challenges them or explores theoretical limits of such things, if there exist any. Like a work that shows, how in computation we have undecidability, uncomputability type results, that in computer science there are certain things that are uncomputable. It does not matter how more powerful you can become, how much more money you spend. With the model of computation, if accepted as a Turing machine, there are problems that are unsolvable, undecidable. that there is no generic algorithm that can decide on every single input. There are specialized inputs you can do fine, but you cannot claim for every input, and you can prove this mathematically. But I wonder just whether some people will come up with things like that, the theoretical limits of LLMs, that there are certain things that in this universe we cannot do with LLMs, and here's the mathematical proof. But I haven't seen any. So maybe there aren't any, but I haven't seen a proof that there aren't any either.
I think they released it in 2024, and then it just got broken, and so now the limits keep going up and up.
Yeah, however you look at it, like even, yes, there is hallucination, but people hallucinate too. I mean, in most of the hallucination I've seen in my work, I see incorrect references over and over and over again. This person wrote this paper, this person wrote this book, this person did this, almost 90% of them incorrect. It explains correctly what the topic is. It explains correctly what the expertise of Professor X is, and says, go look more in Professor X's paper. No, Professor X never wrote that paper or that book, but just glues, as you were saying, glues things together. Sometimes this gluing leads to this kind of mismatches. But is it really a foundational limit, or is it something that will get better as we teach it more and we warn it that this person didn't? Yeah. It's really fascinating topic, and and I don't know, even there are no works even on what the impact on financial economics will be. If everybody used LLMs in everything they did, and only LLMs in everything they did, will that make markets more efficient? Will really, like, true efficiency of markets, efficient market hypothesis will become actually a theorem that it is true because everybody's doing. There is nothing that you can do except news, because we are all doing the same thing. So interesting, but nobody really touches upon these things, and I guess there isn't much money in that either, I suppose. So, all right, Jiri, anything to add to conclude the night or the morning for you?
I would like to thank for organizing this webinar. It was amazing, your questions and your notes. I would like to thank you very much.
Thank you. It was excellent.
Thank you.
Yes.
Excellent. Thank you so much. Right. Thank you. Bye.